This problem is related to the concept of work energy, buoyancy force and viscous force. Problem says a table tennis ball has a radius of 3 by 2 into 10 to the power minus 2 meter and mass of 22 by 7 into 10 to the power minus 3 kg. It is slowly pushed down into a swimming pool to a depth of d, which is equals to 0.7 meter below the water surface and then released from the rest. So this is the table tennis ball, mass is given and radius is also given. This ball is slowly pushed to a depth of d and from this position it is released. It emerges from the water surface at a speed v without getting wet and rises up to a height h. And this ball comes here on this surface. At this point, at the water surface, it has a velocity of v. And that is why it further rises and it rises up to a height of h. Then we have to find which of the following options are correct. Some options are given and we have to find which options are correct or incorrect. Constants are given, pi is given, g is given, density of water is given and viscosity of water is also given. So let us try to solve this problem. So we will take each option separately. So let us take the first option, that is work done in pushing the ball. What is the net force on this ball when this is inside the water? The one force that is acting, that is mg. And another force, that is buoyancy force, that is v rho w times z. So what is the net force? Net force is v rho w into z minus mg. So this is the net force that is acting in the upward direction. And if we want to push this ball down, then we have to apply same amount of force in the downward direction. And then this distance is d. So work done by this force, that is external force that we are applying, is equals to this times d. So work done is equals to this force times depth d. Now remember, this ball was slowly pushed and that is why velocity at each point is 0. So there will be no viscous force because viscous force depends upon the velocity. Viscous force is equals to 6 pi eta r v, but v is 0 because this ball was slowly pushed. So work done by viscous force is 0, or you can say there is no viscous force acting because the process is very slow. Now let us calculate this value. So this is the work done. Volume is 4 by 3 pi r cube. Density of water rho w, z is given, m is also given. So now I can plug all the value. So this is 4 by 3 pi and this is radius and this is z and this is rho w and mass is given, this is mass and this is gravity and depth is 0.7 meter. So if you calculate this value, the work done in pushing this ball at a depth of d is 0.077 joule, and that was the option. So option A is a correct option. Now let us see the B option. And the option B says, if we neglect the viscous force in water, then the speed v is equals to 7 meter per second. So let us check this option. When ball is released at bottom, same amount of work will be done. So now what is happening? So we push this ball from here to here and we did a work of 0.077 joule and the ball was moving slowly, that's why we neglected the viscous force. But now in the question itself it says neglect the viscous force. This means when this is going up again there is no viscous force. Basically in actual there will be a viscous force because this ball is going up and its velocity is increasing, so there will be a viscous force. But the question says neglect the viscous force. This means the work done is same. The work done from here to here is same as work done from here to here. So in the downward journey and in the upward journey, work done is same because in both cases viscous force is neglected. In one case it has been assumed, in another case it was slow movement. So work done is equals to 0.077 joule, and this is the work done by the external forces. External forces in this case is this mg and v rho g. So effective external forces will be due to this force. Now work done is equals to change in kinetic energy. Here we have kinetic energy 0 and final kinetic energy is v, half mv square. So final kinetic energy half mv square minus initial kinetic energy, which is equals to 0, and this is equals to work done by the external forces. And in this case work done by the external forces is 0.077. Now if we plug the value of mass and calculate for v, then I can rewrite this is v square is equals to 2 times 0.077 and divided by mass. So this is mass. So from here I can say this velocity when it reaches on the top of water surface is 7 meter per second. So this means option B is correct. Now let us check the third option, that is option C. Once again it says if we neglect the viscous force in water, then the height h is equals to 1.4 meter. So this has reached here and we have just calculated if we neglect the viscous force, the velocity at this point is 7 meter per second. So now I can use the formula, the kinematical formula, v square minus u square is equals to 2as. So final velocity will be 0, initial velocity is given, that is 7 meter per second square, per second not a square, and g is also given. So final velocity is 0, initial velocity is v, and this in this case acceleration is z. Then we have to find h. Basically you have to consider negative sign here. So there is a typo, negative sign because this g is acting in the downward direction and this is going in the upward direction. So this is decelerating and that's why there will be a negative sign, and this negative sign and this negative sign will cancel. So the height will be simply v square by 2z. V is given and z we know, so this is 2.45 meter. But in this case the question says h is equals to 1.4 meter. So this option is incorrect. So option C is incorrect. Now let us look at D option. And this option says the ratio of magnitudes of net force excluding the viscous force to maximum viscous force in water is 500 divided by 9. So we have to find net effective force or net force without the viscous force, and then we have to find maximum viscous force, and then we have to take the ratio. So if you remember, the net force was V rho g minus mg. We can plug all these values and then we can calculate. Volume is 4 by 3 pi rq and this is rho w times g minus mg. If we plug all these values, this force turns out to be 0.11 Newton. So this is the net force. And what is maximum viscous force? Viscous force is equals to 6 pi eta rv. This formula you have to remember. And this will be maximum when velocity is maximum. And the maximum velocity is when it just reaches at the top, that is 7 meter per second. So maximum viscous force will occur when it reaches at the top surface of the water. At that point of time the velocity was 7 meter per second. Now eta is given, So this is 6, pi and eta, r and v. So if we plug all this value, we can calculate corresponding viscous force. And this is equals to 18 into 11 into 10 to the power minus 5, and if we take the ratio, that is 0.11 divided by this value, this is equals to 500 by 9. So this option is correct. So option D is correct. So I hope you enjoyed this problem, and if you like my videos, please share with your friends, like on my channel and subscribe to my channel. I will see you in the next video. Thank you.